The gravity of the time is such that every new avenue of peace, no matter how dimly discernible, should be explored. Never before in history has so much hope for so many people been gathered together in a single organization. You will provide a great share of the wisdom, of the courage, and the faith which can bring to this world lasting peace for all nations and happiness and well-being for all men.
Okay, so we're here today on Titans of Nuclear with Scott Bailey, who's the VP of Supply Chain at NuScale. Scott, welcome to Titans.
Well, thank you for having me.
Yeah, no, super excited to learn about your work. But before we get there, we'd love to just learn about you as a person. Tell us, where'd you grow up?
Well, great. So I'm a New Englander so that makes me a Red Sox fan and a New England Patriots fan. But I grew up in Maine and lived there, the first 40 years of my life. I went to college there. I went to the Maine Maritime Academy, marine engineering. And I worked I did a little bit of shipping work out on deep sea. And then I cut my teeth in nuclear in 1986 at the Maine Yankee plant. So I was there for 14 years, various positions.
Before we get to that plant, why don't you just tell us what got you into maritime originally? Why'd your interests end up going there?
So a couple of things is one that I'd always been interested in, the ocean and boats and ships and all of that stuff. But also I was a little bit of a fix-it guy, meaning that, working on things around the house and those kinds of things, lawnmowers or whatever it might be. And the Maine Maritime Academy is a little bit, it's kind of a combination between technical and a trade school. So even though you do get a BS degree, I get to learn how to weld and do machine tool operations and operate power plant equipment. So that was definitely an interest of mine. So, and then, moving on from shipping, I've pretty much been in power generation my entire career. So, starting with the ships and then moving up through the nuclear power plants and so on.
So when you were working on the ships, did you work on the ship's engines or?
Yes.
And what types of ships were these?
I was a watchstander, so I spent part of my time on a diesel ship, that was a freighter. Then we would just carry goods from one location to another, almost like a taxi. And then I spent the last part of my tenure out in shipping down the Gulf of Mexico, where I was the engineer on supply boats. So we were taking equipment out to the out to the oil rigs in the Gulf of Mexico. So
I've always been curious, what happens if an engine stops working, like when you're in the middle of the ocean?
So generally speaking, you've got multiple sources, like particularly like on the supply boats that we had twin screws, or in some cases three, where so you had a second engine. But if on the larger ships, you basically have to fix it, right? So,
and can someone fly out with supplies, or are you all on your own?
Well, there's a reason why at the Maritime Academy they taught us how to weld and how to use the lathe, because you generally, sometimes you could get a port engineer and sometimes you could fly out some goods and things like that if you needed them. But generally you fixed it with what you had and you got it going again. So.
And what's the worst case scenario? Is it even possible for a tugboat to get out there, or is that not?
Well, it depends. It really depends on how far you're away from port,
yeah.
Right? Now, fortunately for me, I've experienced what I'll call losing the plant, where we lost main propulsion, but we got it back. And it wasn't in a we weren't in a maneuvering situation like when we were in a port or something. We were out to sea. So, all you did was get the bridge yelling at you and saying, "Hey, what's going on down there?" So, but we'd get it back up and running, and all was well. But
and how big are the engineering crews on a ship like that?
Oh, I was the only one in the engine room at night. So it was me. So on the 8 to 12 shift at night, that was just me. So but generally the crews were, it depended on whether you're a steam plant or on the diesel, but I was on the diesels, and we generally had a crew of 1, 2, 3, probably about a half a dozen total.
Wow, cool. Okay, yeah, so I bet there's some fun adventures there.
Yes. Yeah, there's some stories. All merchant mariners have some stories.
Okay, so then you come back landside and you start working at Vermont Yankee. Is that right?
No, Maine Yankee.
Oh, Maine Yankee. I'm sorry. Maine
That's
Yankee.
all right. That's all right. So I was at Maine Yankee for about 14 years. So I was there from 1986. I started out as a quality control inspector. So I got to climb over all the pipes, and as I often tell people, I get to go places where many people didn't get to go because
Like where?
They didn't. Well, I mean, like inside of the steam generators and things like that. So and down in some of the pipe tunnels where there's not a lot of activity, but if there's a valve down there that needs an inspection, then I went down there, right? Whether it was a high radiation or not. So it was a good experience because I really got to learn the plant, get to do that kind of stuff. And then I ended up over in the engineering department. I ran their procurement engineering group for a while, and then
and before we get too far along, what kind of plant was it? What was the configuration?
It was combustion engineering, PWR. So
like a 3-loop or a 2-loop?
Yeah, it was a 3-loop. Yeah, it was a 3-loop CE plant. And of course, at the end, it was Westinghouse when they bought them. But so I ended up in the procurement engineering group after that. I spent a lot of time in when I was on the QA side of the organization with a lot of supplier quality related stuff. So I started their procurement engineering group at Maine Yankee, and then eventually I ended up in supply chain in the mid 90s.
So you must have had a pretty good understanding just of plant reliability overall. Tell me, from the time that you started in 1986 through the end of your career there, what was like the primary differences in maintenance issues like over that time period? Like, how did it change?
Yeah, well, so with some of the post 3 Mile Island modifications and stuff that we did, so there was a lot of changes there where we had to install, I'll say, a lot of modifications to the power plant. But I would say probably the biggest changes, because I got to experience a lot of change in the nuclear world. But I would say some of the biggest changes were the focus on shorter outages, managing your project managing a little bit better. I mean, I was working at Maine Yankee during the time when outages went from a few months down to several weeks, right? And a real attention to detail and focus on shorter outages and reliability. On the supply chain side, we found ourselves really trying to deal with the obsolescence kinds of issues and trying to keep the plant running with parts that are no longer available by the various suppliers.
Is there a specific part or component that kind of plagued the whole industry from an obsolescence perspective?
Yeah, I think some of the electronics, perhaps some of the stuff in the reactor protection systems were some of the areas, some of the electronics, because as you well know, the industry was moving much towards digital, but in the existing fleet, we did whatever we could do to maintain our analog designs, because going through a design change was very costly, time consuming, and troublesome. So we spent a fair amount of time trying to keep our more analog systems operating, right? So that, but suppliers had abandoned some of those, some of those product lines. So that created some challenges for us.
And in your opinion, how come the industry just never moved towards digital? Like, why was that just so tough?
There's probably a lot of reasons, but I do think that the regulatory hurdles in order to make some of those changes they're fairly big, right? And then of course you typically got to do the installs or during a shutdown, which has the potential to extend your shutdowns, and obviously a plant at rest is not making its owners any money. So I think it was a combination of the time and time and money, right? I think in the end, and we'll talk about NewScale in a little bit, but we had the opportunity to bypass all that pain.
Right. Start right from the beginning. Okay,
Yeah.
so what was your next step in the nuclear industry? After
Yeah. So I went through the horrors, if you will, of going through a plant shutdowns, because Maine Yankee made a decision to shut down in, I think it was 96. But
why?
In the end, it was economics, right? Our owners, they were going through deregulation in New England. We were in a situation where we were currently shut down and on the NRC watch list and those kinds of things. And our owners felt that it was probably in their best interest to shut the plant down versus them trying to put more money into it and to restart it. So we were the first at the Maine Yankee plant. We were, I think, the first, but if not the first, one of the first plants to actually go on the auction block, so to speak, being sold. So it was during that period of time when, people like Entergy and Dominion and others were starting to, at the time, Philadelphia Electric, which later became Exelon, they were looking at purchasing us and then couldn't strike a deal with the owners. So we ended up going the decommissioning route. So I spent the first 5 years or so of shutdown, at Maine Yankee, working on decommissioning. So in a way, getting to NewScale is kind of going full circle, in an odd way. Operating plant, shut down plant, now developing new plants. So I'm pretty excited to be on this side of the cycle versus the decommissioning side of the cycle. But so I was there until 2001. So I was, which was prior to them completing decommissioning, but I was looking for a change after that and said I'd been doing decommissioning long enough, and I ended up, I'll say, exiting the nuclear industry a little bit. It's one of those things, I don't think you ever exit the nuclear, because kind of once you've been tagged as nuclear, you tend to be nuclear all the time, right?
And because you developed a very unique set of skills that's very valuable. So, people know where to find you and when they need you.
Oh, yes. And they're always hunting you down. So no matter even if you were trying to escape nuclear, it's awful hard. But I went to a startup company that was working, this was in the early 2000s. So think about the .com boom and e-commerce and e-marketplaces and all those things so I went to work for a small startup company that was working in the utility space, right, in the e-commerce, and I ended up staying there for several years, and then after I left them, I went to a consulting company. And so in that period of time, in the early 2000s until 2007, I was pretty much consulting. So during that period of time, I think I worked for 14 different utilities, sometimes fossil, sometimes nuclear, but always power generation. I was always focused on the power generation side of the business, generally representing the owner, right? So when I was doing consulting work, I was consulting for the utility owners. So like I said, I worked for a bunch of utilities, which was great experience for me, because I got to see a lot of different ways of, how people ran their organizations, what their processes were, where their hard spots were.
Yeah. What's the biggest difference? If you could explain, just the range of ways to run your procurement and your supply chain, what's on one end of the spectrum and what's on the other end?
Yeah, well, I think what I would say is that certainly on the fossil side of the house, there was such a, because I worked for, and in 2007, I went to work for an independent power producer, basically NRG Energy. They had nuclear assets, but I was not, involved in that. I was responsible for their fossil assets. So I would say the largest difference that I saw there was efficiencies, right? Meaning uh, less infrastructure, less, less, I'll say less procedures, but maybe less detailed, right? Because we obviously had procedures and policies and things that we passed, but we were generally a pretty flat organization. At the time when I left NRG Energy, I reported to the chief operating officer, who reported to the president, right? So I mean, we were pretty flat, and I had responsibility for all of the supply chain for all of the operating plants. And at the time, I think we had 30 something, 34, I think, power plants that
Wow.
we had. So I had 100 some odd people spread out across coast to coast, right? But it was a pretty flat organization, which the bigger differences I see on the nuclear side particularly is that much more infrastructure, much more procedure, much slower decision-making processes, and so on and so forth. So I'd say that's the biggest difference I experienced.
And like, what would be something that would have gone slower for decision making? Like, if you got an existing asset and it needs a pump, don't you just get a pump? Like, what's the
Right. And that's actually a pretty good example, because in the power plant, you'd sit with your power plant engineers, and you would go out to the market and see what was available and see what pump would work in that application. In the nuclear side, we tried to figure out how we could identically match and do a like for like replacement, right? So we didn't have to go through a design change. So the design change process was a lot simpler. I mean, when in the fossil side, when a manufacturer came up with a new widget or a new design of the widget, we'd take it, right? We'd say, oh, this is more efficient, and it fits on the same foundation, or it fits in the same brackets, and it's still
uses
work.
about the same amount of power, about the same physical size. It's better. Yep, plug it in.
And then we'd put it in place and test it and said, yep, that works exactly the way we wanted it to work. And then it would be running. Whereas that evolution might take, a few weeks in a fossil plant. It could take, months, for a nuclear plant to go through that. And part of it obviously is for the safety aspect of that, for the nuclear safety aspect of that. So you understand that.
Yeah, though it is interesting. I mean, there are like safety concerns inside of like giant fossil plants too. Let me ask, like, did you have to if you were going to replace a pump, did you have to tell anybody? I mean, obviously within your organization, but I mean, like outside, is there an equivalent regulator for fossil
I think
plants?
that, well, because you do have some, and this isn't really my area of expertise, but you do have obligations to the grid operator. So if you were going to shut down your plant, the grid
but
operator.
you don't have to get an outside organization to sign off on which pump you chose.
No, exactly. No, exactly. And technically, you don't even really to do that in the nuclear industry. You just have a much more robust set of procedures that you have to follow.
Got it.
Right. Whereas in the fossil side, you still had the procedures, and things were done certainly from a safety perspective, but it was mostly about personnel safety and asset protection versus nuclear safety, which is a different bar.
Got it. Yeah. So tell me, how did you end up working for NuScale?
So I told you I went at NRG, and then I was at Tennessee Valley Authority. I was there for a little over a year, and I was working on their nuclear. I was in charge of their, the procurement for their nuclear projects on that side of the business. And actually, a headhunter found me there, and it was right about the time, it was the late 2000s. So there was a little bit of the renaissance going on at that period in time. I had been kind of eyeing nuclear, which is how I ended up at TVA. But So a headhunter talked to me at first. I was like, oh no, I just got here at TVA. I'm kind of happy here. And then and then he kept bugging me, and then it started with the, okay, I'll have coffee with you. We'll talk about it. Right. And then I went out. Then I went out to NewScale, and I've been with NewScale a very long time.
Yeah,
in
you're
fact,
one of the early guys.
I'm one of the early guys. I started in January of 2011. In fact,
Wow.
on the executive team, it's kind of a badge of honor for myself is that other than Jose Reyes, which he's been on the podcast before, and he's my personal hero, and we'll talk about that in a second. But I've been with the company as long as everybody except for Jose. So,
Amazing.
as far as the executives go. And there's
Wow.
probably about 35 or 40 employees that have been at NewScale longer than I have. So I've seen a lot.
So what attracted you to the original vision? And I also want to ask, has it changed? Because we all know startups have to like pivot occasionally. Have there been any major, like if you go all the way back to 2011, like in those early few years, were there any major design changes that you were part of?
So I wouldn't say so much as design changes as much as the changes in the company. So when I had gone for my interview, I interviewed with Jose, right? And Jose spent a fair amount of time with me explaining to me what the design was, and I was sold instantly, right, on the design. And
Which
that's
characteristic? Which characteristic of the design?
the simplicity, because from a supply chain perspective, everything was, I'll say, more complex than it really needed to be, or at least it seemed that way. The fact that
In old nuclear, you're saying in old nuclear, and this
old nuclear had a lot of moving parts. Old nuclear had a lot of dependence on safety related electricity, and a lot of moving parts, pumps and tanks and various methods to keep the fuel cool. And when I saw the NewScale design, I instantly saw that this is the answer that we've been looking for, and I need to be part of this. And that's kind of how I did it. It was risky at the time. We were, it was pre-Fluor. It was before Fluor came in. It was before we had any Department of Energy funding. So it was kind of a rough, a little bit of a rocky start, for me, but it's, that in itself is a good story. But maybe we'll get to that later. But I knew that we were onto something. I had my doubts whether a small company, that was, starting up in Corvallis, Oregon, could do it, but I'm also not afraid. So, and I felt that, if this is something that I believe in, is something I want to do, then I'm just gonna saddle up and let's go.
Amazing.
Right. And
amazing. Yeah, no, I do want to hear about some of those rough bumps early on. Tell us, what were some of the early changes?
Well, my first day of work is I'll say it was probably the roughest start, because literally the first day of work was when we were notified that our primary source of equity, of funding, his assets had been frozen by the SEC, right? And so we had no more money.
Wow.
So that was my first day of work. As a matter of fact, the CEO at the time, Paul Lorenzini, walked into my office, and I hadn't even taken my jacket off. And he said, "Scott, we need to talk." So that's when I learned that, that we were in trouble. And I told him, I kind of knew that this would be risky, but I kind of thought I would get through the first day.
Yeah, first day, first week, maybe first month even.
Yeah, right. So, in my first week was, my first week was pretty adventurous, because I had, I had to suspend basically terminate all of our contracts and put the suppliers on hold. So I had to call all of our suppliers. In fact, I put out a notice Thursday that week, that froze the work.
So I'm curious, back then, because it's like you were still in the earliest design stages. So what suppliers were supplying stuff?
Oh, no, it was, so suppliers were designing things for us.
I see.
So that's one of the unique things about NewScale is that, while we design, things like the NewScale power module and some other minor, other components, we generally rely on the supply base. We tell the supply base what the product needs to do, right? And what the functional specs are for the product, but we let suppliers design their own products, right? Because they
And
know how
wouldn't
to
they
do
be
it.
willing to do at least conceptual design work for free with like the promise of a
Yeah,
possible new market
actually,
entry?
we had so after I made that notification to folks, generally suppliers don't work for free. I suppose that's the way they make the way they make money.
Yeah, but you kind of assume like, they'll put a couple engineers to do some like, heat exchanger sizing calcs for
Oh,
you,
sure.
like a
We
rough
get
quote.
we get that kind of support all the time. It's when you get into a detail. But even during this period of time when we had to issue the stop work order, we had several suppliers that just said, we believe in you. We're going to keep working.
Yeah,
Right.
that's great.
We're going to work on our own dime because we don't want to lose time on the schedule. So we really learned that we had friends in the nuclear industry that also believed in us, and that was a very heartwarming kind of thing there. So that period of 2011, from my first day of work up through to the point of time when Fluor entered the picture, later that year was kind of rough. I mean, we all took cut and pay at one time. We were all we'd furloughed like 30 employees and about 40 of us were on minimum wage, right? My son thought that was interesting because he said, Dad, now I make more money than you. And I just kind of laughed. But the point being is a lot of people made a lot of sacrifices in those early days, and that's kind of what I had other opportunities. I could have gone back to TVA. They would have worked something out. I had a couple other colleagues that I knew out in the industry that said, just come work for me. So I had several other opportunities, but when I learned what NewScale was doing, I just said, no, I'm going to ride this thing out. I don't know where it's going to go, but I'm going to ride it out. So.
And what level of design is owned by NewScale versus like where does the NewScale technology stop and the rest of the power plant, whoever owns that intellectual property, begin?
Yeah, so generally speaking, if we pay for it, we own it. So we own the rights to it. But if you're that familiar with intellectual property kind of roles, is that always get tangled up in background IP, which is IP that the supplier brought to the table, and then foreground IP, which is that IP that's developed as part of your project. So generally speaking, a supplier keeps the rights to their background IP, and we have license to use it, right? And generally speaking, the foreground IP we own, right? So if there's any IP that was developed, we get to own it, and oftentimes we'll license that back to the supplier as well for uses that are what I'll describe as non-competitive kind of uses. So that's generally how that works out. But the actual the intellectual property that sits behind the magic of the NewScale plant, that's all owned by us.
Yeah.
Right.
And then at the end of the day, in the NewScale business model as it exists today, who is responsible for, I guess, the final delivery of power? Is it NewScale, the company that has the warranty on actual electrons coming out of the facility, or is that like an EPC that sits on top of NewScale that has to package all of that up, and then NewScale is responsible for the core?
And generally speaking, it can differ a little bit from whatever the owner desires. In our particular case, there's a NewScale scope of supply, which is my responsibility. And then there's an EPC scope of supply, which is Fluor's responsibility, in particular, as we talk about the carbon-free power project in Idaho. So we have a division of responsibilities that we have within, with Fluor. So there are certain things that I'm responsible for, which means I'm responsible for everything, for instance, NewScale is responsible for the NewScale power module. right? And the thermal output of the NuScale power module, which means we'll warrant that.
Does it extend into the balance of plant and the turbine island as well, or is that on the floor side?
That's on the floor side.
Got it.
So the floor.
So you
the
guys
floor-
are like, you guys are the nuclear island, maybe minus the civil site work,
Yeah.
and then the EPC is everything else. Essentially.
Yes. Yeah. That's accurate. That's accurate. So, and we have the benefit that, other developers don't really have. Well, one of the benefits is that we've been, because of Fluor's ownership position with NuScale, we've been working with Fluor for 10 years.
Yeah.
Right. So, you don't usually see that. Usually the EPC and the OEM kind of merge, I'll say, later in the process, but we've been working alongside each other the entire time. So
now, you guys have had a lot of successful announcement recently across the world. How does that change things? If you're building a power plant in Romania, I think Romania was one of the more recent announcements.
Yes.
Is Fluor still the EPC there, or do you have to find a Romanian EPC?
And generally we leave that up to Fluor. So obviously they have, as part of being an owner, they have rights, right? And what they'll do, and I won't speak for them, but generally speaking, they'll figure out, is this a market that they want to self-perform in, or is this a market they just want to do oversight on? Is this a market that they want to partner with somebody on? So they'll take a look at that, and we won't worry about that, so to speak, right? Fluor will take care of that. We'll still work on, our scope of supply and how that gets delivered. But you bring up a valuable point that as we start to spread out into, other countries, particularly, like in Eastern Europe and Canada and other places, is that there's always a demand for local content.
Exactly.
Right? Everybody wants the jobs, right? Which is, we've recognized, and our plant is very unique from that perspective, because most everything that we have, or with the exception of some of our most sophisticated kind of items, they're pretty much built to print, right? Which means that if you have the capability, then the work can be localized. Canada is a great example. They're an industrial nation, right, with all kinds of capabilities. They can build the NuScale power module. They can build it at BWXT.
Right. Oh, so you're saying that you would actually have not just the balance of plant locally sourced internationally, but even the power module, the nuclear core itself, could be built internationally.
It can be. It depends on the capabilities.
But I guess why do that? Because you're definitely going to get efficiencies from your when you build your first factory that produces these modules, you're going to want to give that one as much business to help pay off the factory. So why isn't there enough in the balance of plant to say, hey, we're like 50% or 60% locally sourced, and then you just have one factory that's just spitting these guys out that you can ship around the world?
There might be, but I need to explain a little bit about what our go-to-market strategy is relative to manufacturing.
Yeah,
we're not going to have a factory starting the block. So the way our design is, it's a number of subcomponents, right? The NuScale power module is broken up into several components that are completely independent of each other. In fact, they ship separately. Right. So whether you're talking about the upper reactor pressure vessel, the lower reactor pressure vessel, containment vessel, top support structure, all these parts of so our strategy today is nobody's going to build a bespoke or a custom, what we call a purpose-built factory, a factory that is designed to build NuScale power modules. They're not going to do that today. So our going in strategy is to use the existing supply base to build the various components. NuScale acts as more of a manufacturing integrator, right? So, and from my perspective, from our perspective, we're going to need pretty much a large chunk of the capability in the globe, right, in order to meet our sales demands, right? So, as an example, we've gone through what we call design for manufacturing process. It's that we did concurrently with both BWXT and with Doosan. And what they did is they went through our entire design and did two things for us. They made recommendations on, how we could make it faster, better, cheaper, right? And then the second thing, which was equally as important, was they went through the process and said, yes, I can build this, right? So we've got two suppliers, right? Two well-known juggernauts in the nuclear industry that have said, we can build this. So we're confident that if we need to expand that to other locations to increase our capacity, that we can do that. And then NuScale acts as kind of the, you know, the facilitator, the orchestrator of, you know, which parts go where. And so it becomes a little bit of a, you know, kind of a little bit more like somebody like a Boeing, where they don't really manufacture a lot, but they assemble a lot. So they
Yeah.
get lots of parts and pieces, and they coordinate putting them all together.
But they do have their own factories to do that integration. So that's what you said you're working towards, essentially.
Well, so our factory to integrate that stuff is literally the site, right?
Oh, I see.
Because all the parts and pieces end up eventually at the site where the plant. So the only difference between maybe a shipyard or maybe somebody like a Boeing, I mean, there's obviously huge differences, but one of the major differences is the fact that we'll put it together in in the field, right, versus the, so it's much more of an assembly than it is really a construction. So you get a lot of components that mechanically you connect them.
And would that be like NuScale employees that physically have the cranes and stuff, or is that like a subcontractor? You got
typically those will be subcontractors. For instance, we have a partnership with Sarens for putting Sarens USA for assembly of large components, right? So they're helping us with that whole process.
Amazing.
Right.
And what is the largest component? Is it that outer vessel itself?
Yeah, the largest component is the upper. It's called the upper NuScale power module, but it's actually the upper containment vessel and the upper reactor pressure vessel. Probably close to 500 tons. So it's pretty big. That's the largest piece, and everything else quite small compared to that.
And then does the and that can be road transported, or how do you?
Yeah, so we have two configurations that we can transport in. One of them requires a little bit more on, we call it near site assembly because it's not really on site assembly. It's kind of an extension of the factory. But if you can segregate the upper reactor pressure vessel from the upper containment vessel, and then you can put that together, at the site. That's one of the configurations that we use for sites that are much more restricted as far as transport goes. Our first site, like in Idaho, being an example of that, because it's not on a waterway. But if we had a location that's, near a barge slip, doesn't have to be on one, because you can still transport over road, but it has to be within, decent striking distance of some sort of water port. Then you definitely would put the upper and the upper reactor pressure vessel and the upper containment vessel together before you ship them.
And why not narrow in on the most restrictive but still applicable design, rather than like maintain like parallel assembly paths and parallel construction paths? Isn't it like, how much could you possibly save? Maybe $1 million, isn't it worth it just to have one thing that you do the exact same every time, even if it is a little bit more expensive?
Well, so the suppliers will be doing one thing. So meaning that the upper reactor pressure vessel or the lower containment or the lower reactor pressure vessel, right? And we believe that there will come a time for a purpose-built factory, because as you're probably aware, most of the what I'll call qualified suppliers or manufacturers of these components are more like job shops than they are production facilities, right? So their shops, whether it's a Doosan shop or a BWXT shop or somebody else's, they're designed where they could make a whole bunch of different things in different ways. So their production layout is not optimized necessarily for the NuScale power module. Of course, they'll do some things to make it better, but it wasn't designed that way. So there will come a time, and when the order book supports it, that a factory will likely get built, because we believe that you can take, we'll be able to shave a fair amount of time off the schedules, right? With
Yeah,
this.
no, I just meant like, why not impose an artificial design constraint of saying everything has to be road transportable? And then maybe after we've built 10 or 20 and we've, then we'll kind of open up the barge for optimization. But like right now, no
So
matter what, everything has to be road transportable, period. In the story.
everything is road
Okay,
transport.
okay, sorry. All right. Got it.
So, right, so the question is, the question is there some more optimum ways to do it, right? When you get into some of these very challenging inland kind of routes, right?
Oh,
That's all
I
I'm
see. I
saying.
see. Because the road actually might be the restriction, is what you're saying.
Yes, the
I
road,
see. Okay,
the
now
road sometimes might be the restriction, so
now I understand.
particularly when you're trying to travel up over mountains. So it was, I mean, obviously in the early stages of the design, they had, Jose and the rest of the team and our design team had to figure out what's the optimum balance between output and size and how big can you make it. But one of the conditions was it needed to be road transportable. So, and
And
it is.
and speaking about output and size, I did notice that after you guys got your NRC design certification at one size, there was like a press announcement that said that you guys wanted to now upgrade the power. Did that cause a headache for you? Did you have to redesign a whole bunch of stuff?
No, actually, surprisingly, very little effects. It was more along the margins. Once you get deeper into the analysis about what the fuel can do and how much heat can be removed and so on and so forth. When we get deeper into the calculations, most of that margin was just recovered that way without making any changes.
And
Any
does
of the
it
changes that we made were subtle.
does it
Were
require a
small.
new NRC design certificate, or does the old one still apply to the new power?
So we're working on what is known as an SDA, which is standard design approval, where we'll make some of these changes on, but it's not really that complicated because we already have an SDA for the existing plant, and the SDA that we'll use for the for the first plant will be, think of it as a red line document, because a lot of the things don't change. It's very, and the NRC is very familiar with the uprate process, right? I mean, that's something that they do all the time with their existing power plant fleet. So this is much more like an uprate review than it is a change in design, right?
Yeah,
So,
the only thing that I would have been nervous about is that, given that it is like a fair percentage increase in power, that some of the physics of the natural circulation and everything might be called into question again, which is like part of the core safety concept, right?
right, and we've run all the codes and all the analysis on that, so we already know what the answers are going to be. We just have to get it in the right format for submittal, right? So we have, we wouldn't have done that without the confidence that we're going to be just fine.
Got it. So where's the first one going to be built?
Idaho Falls area at the Idaho National Labs. Well, we say that is the first one because they're the most advanced in their their whole selection process and their whole contracting process and all of that. But we follow much more of a philosophy of ready when you are, which means that we're working very hard, particularly on the supply chain, to be able to deliver modules by 2027, even though that's earlier than when UAMPS needs them for the carbon-free power project. So we're doing the activities necessary to be able to deliver sooner, just in case somebody decides that they want to step in front of UAMPS, which is I mean, people like Romania, some of them, their stated objectives are earlier, right? So,
But so how does that work? Yeah, from a supply chain perspective, if we don't know who's going to be the first, don't we have to like make a decision at some point and just say, okay.
you do, but there's plenty of time for that decision. There's so much time that has to be involved in the long lead material purchases and those kinds of things.
What is the longest lead time component? If you
It'll
had
be some of our large forgings that go in the upper reactor pressure vessel. I mean, the longest lead from a critical path perspective, it goes through the upper reactor pressure vessel, because that's the most complicated piece of the NuScale power module. But I mean, we're ready to order long lead material, in 2022. We're ready, right?
So yeah, so what do you need? You just need a PO from a customer essentially, and then
Yeah, it needs, I describe it a different way. Somebody has to fund it, right?
somebody has to pay for
And
it.
whether that's NewScale, the customer, I mean, obviously the customer, is where you would expect that to come from.
And how come it
Um,
can't just be financed off of a PPA like renewable projects are, where you
there-
have the contract from a credit-worthy provider, and then you go out to the financial markets and they just give you a bunch of money?
that there, like I said, there's a number of ways that that you can fund it. I look at it pretty simply from a supply chain perspective, is I'm the agent here, right? And I'll order it as soon as somebody tells me they'll pay for it, right? So and we're working on various things that various options to get kind of a head start on some of this stuff. And we'll work through those details, but in the end, the money's got to come from somewhere.
Yeah, I kind of feel like in order to deliver faster, right? Because the sooner that you can deliver, the sooner you can start printing that energy money. That like the longest lead time components, you just kind of maybe order on spec, even without a customer. Like that, the one that you're talking about, how expensive could that possibly be? Like
Yeah, I mean,
$5
we're
million
in
bucks
the,
or
no, it's in the millions, but low digits, right? So there are some things that can, and that's why I said that we take a look at strategically what's the most important way to spend money, what's the sources of funding. Obviously the government has helped out in a number of different ways. So there are a number of different ways, but you're exactly right. There's a kind of a natural conflict between the utilities and the owners generally want to wait as long as they possibly can to write checks, right? And the manufacturer, like or the manufacturing integrator like us, we want to order as soon as we possibly can, right? So that, but they're naturally, they're kind of opposed to each other, and that's just kind of the way the market is. Without and that's where the government has helped a lot. Certainly has been a tremendous amount of support to both us and to UAMPS, because they're trying to reduce some of that front end risk, like the early risk, right? So they've front end loaded some of their support to the UAMPS project, so that they can place orders to NewScale, and we can start ordering stuff. So.
Yeah, it must be kind of frustrating. I mean, it's even frustrating for me a little bit, like as an outsider looking in. I'm like, what's the holdup? Like, we know UAMPS wants to do it. I think the government gave them like $1 billion. Like, can't that $1 billion just go to start buying equipment?
Yeah, see, now you're getting into all the government funding and how much can be released a year, and the processes that they have to go through, and so on and so forth, and the strings that are attached to some of the money. But no, we're confident the time is there. We're anxious to get started. We'd rather get started earlier than the schedule says we need to get started, so that we get through all these processes. But one thing I want to make sure that I shared during this conversation is that although we're categorized kind of in the advanced reactor category, this is really old technology repackaged in a different way. So the things that we're having people build are not things that they don't have experience building. It's not, we build steam generators all the time in our industry. This NewScale power module is very much like a steam generator in terms of size, right? In terms of complexity. I mean, the outer containment vessel, for instance, is it's just a big round thing. Well, it's actually not round, but you know what I'm talking about. It's not really
like
all that complicated, right? And the industry has a lot of experience. Our fuel, it's the same fuel that that Framatome builds in the existing reactors. It's just half height, and we've made some adjustments at the top and the bottom for our flow characteristics. But it's a well-known fuel. I could order that fuel from Framatome today in Richland, Washington, and they would start manufacturing. So we're, and even our valves, whether we're working with Curtiss-Wright, Target Rock, or Enertech, or some of the other folks, valves that have been used that we made some slight modifications for our application, right? So it's like, we know how to build these, we know how to test these, we know, so this is,
Any new
yeah.
materials, any new alloys or any new metals that haven't
Well,
been
we're
used?
starting to, I mean, we're looking at some materials in the, for instance, in the reactor vessel and the containment vessel that, but they're not, I mean, they're allowed by the code. We have experience in the industry. We're using some materials that, I'll say in a little bit larger forgings than have been done in the past, right? So, but we mitigate those risks through doing tests in advance to make sure that we're getting the, proper grain structures out of the forgings and all that stuff. So we have a very robust manufacturing trials program where we've been doing, we've been doing cladding, we've been doing, building forgings, we have done, weldability tests, we're doing tube bending tests, we've got a lot of things going on in various factories across the world, quite frankly, as part of our de-risking, just to make sure that we can, on paper and modeling, and the engineers and the manufacturing engineers say, yeah, we can build it, but we're still doing a lot of prototyping and a lot of manufacturing trials just to prove it. So that's what we'll do in some of these materials, but it's not like we got to have any code changes because the codes already allow these materials. They just haven't been utilized in, as big of a, big of a forging as that we're going to ask for, right? So we're working very closely with the forging suppliers. We have been for years, right? We've been working with both US forgings and companies like Doosan, right, on, making sure that we can build the forgings we need to. So, yeah, as far as the materials go, like I said, just different applications for materials that have already been used before. So we just got to make sure that our application doesn't introduce any risks that we hadn't, intended. Like we did cladding. Nobody's really clad both sides of a pressure vessel, right? In terms of so we've done cladding distortion trials where we actually.
And you have to
built a
clad
forging.
both sides to resist corrosion because
Yes.
it's in a pool.
Yeah, because both sides of our vessel are exposed to borated water, which is, for the SA 508 is a challenge. So we clad both sides. So, but what's going to happen in terms of distortion, right?
How come you guys
terms-
clad both sides and just didn't make a stainless steel pressure vessel like through?
Well, we actually do have, now you get some of the engineering stuff that I won't be precise on, but some of the materials that I talked to you are stainless steel so that we don't have to clad, but we are doing some cladding on the upper reactor pressure vessel. So that's
And what's the minimum number of modules that a plant can run on? Can you get this started with just one module?
Sure, you could. So the way that we're set up right now is our standard plant design is a 6-unit facility. So the CFPP, the Carbon Free Power Project, has asked for a 6-unit facility. So that's what we'll call our standard plant design. But we have already we already have what I'll say a 4-unit facility as well as a 12-unit facility where we've done enough work on that we know what, and primarily the differences are in the building, the reactor building. From a module perspective and from even the balance of plant that supports that module, it's all the same, right? Whether
And
you
you
got
can-
one or whether
And
you
you
got
can
12.
run the steam, whatever steam turbine you have, you can run that at 1/6 steam flow.
No,
If
they
you only have like
go-
one connected, could you run it on? just-
we have one turbine per reactor.
Oh, you have a turbine for each reactor. Oh, okay,
Yes,
I didn't
sir.
realize that.
Yeah, so which makes it we're
Well, then,
really
yeah, why-
industrial sized.
Then why have your minimum viable product be a 6-pack? Wouldn't this just been way easier to just build one and just kind of show that it worked for 1/6 the equipment cost?
Yeah, you could. Yeah, you could if somebody were willing to pay for that. But the economics, obviously, because there's a lot of I'll say sunk costs in the infrastructure and the buildings and all of that stuff that incrementally to go from 1 unit to 2 unit to 3, it's not really that much, right? And the payback that you get is, pretty significant on adding modules. So the real bigger question is how much power do you need? How much power do you want? If you're replacing coal plants, which is something that we're very adept at, we fit right on coal sites. and can use the existing infrastructure. A lot of times those are in that 300 to 600 kind of range. So you're looking at your 6-pack kind of, your 6-unit facility. So that's really, and so the economics just get better the more modules that you have. So trying to get that balance. It was 12 units for the longest time was considered the optimum size. And that was based on a lot of feedback that we got from utilities as to what they wanted. Then when we went to the 77 megawatts electric per unit, then we got better into a sweet spot where people felt that the 462 was a great place for them to be, right? So I'm not sure what will be the, I'll call it the version that ends up taking off the most, because I do think it's very, very site specific. I mean, if you're out in a very, very remote location that's currently using diesel fuel, you might be able to do a 1 or a 2-unit facility and it's still, the economics might work for you, right? Whereas you're in you're replacing maybe twin coal plants on a coal site, then maybe you're looking at a 12-unit facility, right? So, but for us to change, it's really not that complicated.
And from a supply chain perspective, in terms of economies of scale, of volume, when do you start realizing with your suppliers, let's say the steam turbine, when do you start getting to negotiate like bulk ordering discounts from your turbine vendor?
Right.
How many units?
Like on the turbine, which is just a subtlety, but Fluor will be negotiating that because that's part of the balance of site work. But they're starting to have those conversations right now, right?
But do you have a sense of like when you hit that like sweet spot in terms of?
Oh, I think in terms of negotiation, I think you get there pretty quick, right? Because the first facility is going to be 6 units, and if Romania does 6 units, there's 12 right there, so you're already starting to get to some numbers. So we think that we're in a pretty good position with respect to negotiations, because it's a little bit of a paradigm shift from, how we've done power plants in the past. We've been onesie twosie kind of power plants, right? When you start talking about NuScale with each module having its own independent system, you're starting to get some pretty significant quantities for everything from turbines to transformers to electrical switchgear to heat exchangers to all of those kinds of things. So we think that that there's quite an opportunity, and you want to keep the plant as standard as you possibly can, right? So much more like they do in automobiles, right? You might have a few options, like we definitely will have an air-cooled option as well as a wet-cooled option for depending on what your site requires. But that will be one of the options. It'll almost be like the Model T. You can have whatever you want as long as it's black, right? But the point being is that, so we're going to negotiate long-term arrangements with suppliers that go with the product, not necessarily the plant. So that's a different way of, because it's much more production line thinking than it is plant by plant thinking, right? So once we get our supply chain up and running, our intent is to just keep it up and running, because we can strip the capacity out pretty easily. So the intent would be once you get the machine rolling, you get it rolling, and then you expand additional suppliers as needed to fill the needs. And then there will come a time when there's enough demand out there and the order book is sufficient where somebody, whether it's us or whether it's our partners or whatever, somebody will build a factory, right? And then they can then max out the capacity of that that factory. So.
And then in terms of like your commissioning procedures, do people want to see a single module like running for 3 or 4 months before they turn on the second module or anything like that? Or can you turn all 6 on at the same time?
Generally speaking, you do it one at a time, but mostly because of the commissioning process, but generally speaking, you can probably, I don't know exactly what the schedule is right off the top of my head, but the first one would go a little bit slower, but the intent would be you put them in as fast as you can, right? Or as fast as the owner needs them, right? So if the owner needs the 462 megawatts, as quickly as you can, then you would commission one, get it operating, commission the second one, and literally do it as fast as safely as you can.
Yeah, I'm wondering because of how that might affect the supply chain. Let's say for those specialized internal forgings, is there a delay between the print of each one? Do you have to order them in batches?
Oh no, no, you bring up a valuable point. So the way we plan this out with our suppliers is that, we plan for the entire plant, right? So a plant worth, right? So, and whether or not the forging orders all go in at the same time, we're still working through some of the details, but generally speaking, your contract would be for whatever you have back to back. So UAMPS is buying 6 units, our contract would be for 6 forges. So the only difference will be when they get delivered, right? And so the manufacturer will be concurrently working on multiple modules at the same time because they'll flow through their assembly line, right? So we just need to make sure that the forgings arrive when they're ready to start on the second one and so on. So
yeah,
so it is
that's what I was wondering, as like in terms of like a supply chain risk, if because of these long lead time components, like I'm trying to figure out what accounts for that long lead time. So let's say a forging takes 3 years from the moment you put an order.
Oh no, we're generally talking a year to no more than 18 months, but generally a year. Okay. And it's really just what I'll call melting getting it scheduled on the floor, melting the ingot, and doing what they have to do, the forging, including either rough machining or whatever machining has to be done before it goes to the factory. And then you got to start welding them together, and because it's a bunch of rings.
Yeah, I guess, yeah, the part that I was trying to think through is if your forger, if your supplier has to do a bunch of, let's say, like custom configurations, set up jigs to like get everything in place, and that's what takes, because like, how long does the literal machining or the literal melting take? Not that long.
Right.
So like what happens between like your first and your second order? Do they kind of tear down that setup because they've got other jobs to do, and then it takes another 18 months to get it set back up again? Or
no,
once
they'll have one. They'll have one,
have that dedicated space for you?
Right. They'll right now. So we've got manufacturing plans from both the BWXT that are literally hundreds of pages long, right? With respect to every single detail. That's one of our advantage. I mean, we've advanced this enough that we've got manufacturing plans. We know exactly, what steps go in what order and so on. So, but the intent would be more of the former, where he talked about when they're done at this station, if you will, the next product is going to come up to that station, right? And this piece is going to move on. They won't. So the lead time is not, it's only lead time for the first one. There is no lead time kind of after that, because they're going to continue to, they're going to.
Right, but I meant like between subsequent plants. Like, let's say you get an order for a plant.
Oh, right.
Do all that, and then maybe there's a delay. Do they tear down that station, or they keep it up for you, hoping the next? Plant?
So we haven't negotiated that, but the intent, if you think about it, is it'll probably depend on how close is the second customer, right? And what kind of risk that either us or the manufacturer is willing to take, because you're exactly right. Shutting down the assembly line doesn't make a lot of sense, right? Because you've got it running, you've got it optimized, you're cranking them out. Particularly by the time you get to that sixth one, exactly how to do it and how to do it as fast. You don't want to have to shut that down. So our going in plan is we're not going to have to worry about that, because there'll be other plants behind it. But we also, depending on how close they are, then we might have to bridge that gap. And we're working on various things with the regulator about, whether or not, because I can envision a time somewhere out in the future where NuScale inventories these things, right? That we,
of course. Yeah, I'm more worried about like, the initial, like, you're getting started, you cranking the engine, it like pitters a little bit, and then like those types of risks. And I guess the other risk that I was hoping to hear how you think about mitigating is, in that NuScale module, there probably is a good reason to want to see one running first and see its performance before building the rest, in case it's part of like the hedge, in case you have to make an engineering change to one of those like critical from like a volume perspective components.
So, from an engineering perspective, and we're pretty confident with the modeling, with the laser alignments and all the other kinds of things that, that kind of issue, the hit that you would take in schedule is probably not worth the risk that you're taking of moving forward with the first one. It's not likely that you're going to run into an issue that, what I'll call a fatal flaw because of all the modeling and so on. So
Even
the
with
is,
like precision tolerancing, like,
Yeah.
if, you say, hey, here's the specs on our tolerances, these pieces have to come within, this small, quarter inch of each other or whatever it is. But then, like, I don't know, they're doing a quenching process and it's a little bit different than they thought. And shit, now it's off by, half an inch or something.
Yeah. So in the first module, we do have what I'll call additional tests that we'll do.
Okay. All right. You are
Right.
doing, okay.
Additional
Those are factory
alignment.
acceptance tests.
Yes,
Okay.
factory acceptance test, plus we'll do some more alignment. We'll do much more on the first one than we will need to do, because once we've got confidence in the process, then we won't worry about it being out in the field with it and having an issue. So yes, there are all kinds of plans that we have in place, because even though you do have all the tools that I mentioned, like for laser alignment and those things, those bring you into a high degree of certainty, but some of us are still old school. I want to see that it fits first, right? So I think as of right now, that's what our current plan is, that we will be doing a bunch of trial fits, make sure the first unit fits the way we need it to fit, that kind of thing.
Amazing. Okay, great. Well, we're about at the end of our time. I want to give you the last word. If there are any kind of final thoughts you want to leave with our audience.
So I think there were the couple thoughts. One of them was the one that this is very unique in how we're applying existing technologies. So and we're ready to go, right? Meaning that licensing is in place. The process is in place, and this is real, right? And we're very anxious to get these units deployed and start the next chapter of nuclear and green energy and so on. So we're very proud to be part of it, and very proud to have come from where our humble beginnings to today. So we're pretty excited to be leading this.
Great. Well, yeah, we're all pretty anxious for that final investment decision to come through. So Scott Bailey, really appreciate you taking the time.
All right. Well, thank you for having us.
And initiate at least a new approach to the many difficult problems that must be solved in both private and public conversation if the world is to shake off the inertia imposed by fear and is to make positive progress toward peace.